Hello there, this is Alana Tuckey, and I've received a question about this problem for Math 131, which is section 3.1, number 27. If you look in the top right corner, where it comes in your particular homework set, of course, might be different, but that's the problem it is from the textbook. So I'm going to click on View an Example, and I'll run you through the example, and that should help you with the actual problem. So we have the winning times for our 500 meter speed skating event have generally decreased since 1972. The winning times in seconds, W of t and M of t for women and men respectively, are modeled by the system, and they've given you two equations here, one for women and one for men. Notice that both are where t is the number of years since 1970, so they're giving you a starter year right there. So the first mission is to use the equations of the models to estimate the winning time for women and men in 2006 and find the errors in our estimates. Okay, so hold on. I need to pull up a program 1 second. All right, let's start by figuring out what our t value is. So for part A, they tell us that the year is 2006. But remember that our starter year is 1970. So that means that t is equal to 2006 take away 1970, which would be 36. You could also get that with the calculator. Like that. All right, so what are we going to do with t equals 36? We're going to substitute in and find the women's time and the men's time. I don't remember which one comes first. The women's time. So let me bring that up. Matter of fact, let me do this right here. So I want the women's time at 36 and the men's time at 36. All right, so the women's time would be equal to, and let's just for the fun of it put in the models here. So we have W of t is equal to negative 0.173 t plus 43.42. And then the men's time is equal to negative 0.149 t plus 39.81. That way I just don't lose it anywhere. And of course, you don't have to use Excel to do this. You can write all this on paper. I just don't have paper available that you guys could possibly see as I'm talking. All right. So let's see, W of 36, that's going to be equal to negative 0.173 times 36 plus 43.42. Sorry, it's getting possessed with me. It doesn't like what I'm doing. 1 second. There we go. I've got that all squared away. All right, so W of 36 is going to be equal to negative 1.173 times 36 plus 43.42. And then I'm just going to make the calculator find that for me. Here, let me move this so you can see it a little bit better. All right, so negative, don't forget to use the negative sign, 0.173 parentheses 36, close your parentheses, plus 43.42. So that's 37.192. And then I'll do it again for the men. 0.149 parentheses 36, close parentheses, plus 39.81. And so there's the man's time. So we have 37.192 here and 34.446 here. And these are, of course, running times in seconds. So I better give it units. So this is seconds and this is seconds. And I'll even color code it for you. So this pink one is the ladies and this blue one is the men. All right, so let's double check with ourselves. And they say 37.19 and 34.45, so we're doing really well there. They rounded it to 2 decimal places, and that's fine. All right, so next they wanted to know the errors, so let's find those. Error is how off you were, right? So from what you expected minus what you actually got in the table. So let me write that out. This is the model value minus the table value. In other words, it's what you predicted with the line minus what you observed in real life. Okay. Okay, so let me copy and paste this a little bit. All right, so for the women's error, let's let's see, we expected 37.192. So we want to take 37.192 and subtract away what we actually got from the real table. So let's go to 2006 in the real table, and you can see it's 37.93. So let's do 37.19 minus, what's that again? 37.93. And then for the men, I'll do 34.45, take away 34.78. I'm going to round to 2 decimal places because the data in the table is rounded to 2 decimal places. So I'm going to do the same. All right, so what is that? Well, you grab the calculator here. So I'll take 37.19 and subtract away 37.93. So what I thought it would be minus what the table said it was. And then I'll do it again, 34.45, take away 34.78, and I get negative 0.33. So this one's negative 0.74, this one's negative 0.33. So there's my women's error and my men's error. Still color-coded. All right, so let's see what else they need. Both the errors are negative since our estimated value was less than our actual value, right? So if we estimated more than our actual value, it would have been positive. Then they want us to compare the slopes of the 2 models. So let's do that. That's part B. Compare slopes. Okay, so the women's slope is negative 0.173, and the men's slope is negative 0.149. Since they're both negative, that means that both men's and women's skating times, this is speed skating, winning skating times, I should say, are going down. In other words, the skaters are faster every year. Oops. Since the women's number is larger in magnitude, and what that means is the absolute value is larger. Oops, my dog is barking. 1 second. There we go. Since the women's times, the number is bigger in magnitude, that means you take the absolute value, and it's bigger, right? The absolute value of the number is larger. Then the women's times are decreasing at a faster rate than the men's. Right? Okay, done with that piece. Let's see what else. So we did the comparing slopes thing. Explain why your works in part A and B suggest there may be a time when women and men will be equal. Okay, so let me write that up one quick. All right, so I think the easier spot to see this is if you look at the intercepts. So the intercepts have it so that, here, real quick, the intercepts are 43 and 39. So the women are a higher number than the men, and then the women are decreasing faster. So the women start off at a higher winning time than the men. Think about what that means. Back in 1973, the women were winning the race at 43 seconds and the men were winning the race at 39.58 seconds. So the women were slower than the men, right? But they're decreasing faster. They're shaving their times off faster. So the women start off at a higher value than the men, but they are decreasing their times at a faster rate than the men. This means that at some point, the men's and women's times will intersect and be equal, since their slopes are not the same. They must intersect somewhere, right? Right? The only way they're not going to be equal at some point is if they have the same slope, which would mean they are parallel lines. Since they're not parallel lines, somebody is going to have to intersect with somebody eventually. All right, and then for part D, we're supposed to use the graphing part of our calculator. So use intersect to find when the times are equal. All right, so that's going to take some calculator doing. Let me grab my calculator, and I want to go to y equals. I'm going to type in, oh, and clear out any old equations if you had any, but I don't. So I'm going to type in the women's and men's times here in equation form, not the ones with the numbers in it, but the ones with the variables in it. So the women is going to be negative 0.17, oopsie, not a comma in there, 73x. And x is this button right here, xt theta n, that one, plus 43.42. And the men's is negative 0.149 t, or x for us, plus 39.81. All right, now that I've got those in there, I'm going to make this a bigger screen. If you're lucky enough, like me, you have a color calculator, you can actually change the colors to match. So I'm going to do that real quickly. And you don't have to put the 0 in there, but I just like it being there. So I'm going to change the color so we can match our gender colors here. So I'm going to pick magenta for the women, since that first one was the women. I'm going to go down here and press enter and move this to blue and press enter. Move down to OK and press enter. And again, if you don't have a color calculator, don't worry about it. I'm just doing that for the sake of it. Okay, so now let's see here. I want to press graph and be able to see the intersect. But the problem is that the lines are way far away from where I'm actually graphing. So you can see that the calculator's trying and it's graphed something, but I'm not looking at it. It's not in my window. So I need to go to my window. I need to adjust it a little bit. All right, so let's go back and think about this for just a second. X for us is time, years, but it's years since 1970, okay? And then the Y is the winning times, and you can see we're getting up into the 40s here for the Y. So if I look here, I can see that, first of all, I don't need to go back in time before 1970, so I don't need negative 10. So how about we start at 0? And 0 would be 1970 for a starter. So you type 0, enter. And then the X max, well, I'm just not sure where this intersection is going to happen. I can see that it hasn't happened in the first 36 years that I have here. So how about making it, I don't know, 80, and we'll see what happens. And if I'm going to make it go to 80, then I should probably have it be 10 here. So that's way it's the scale, it's the distance between the tick marks, right? So every tick mark's worth 10. Now the Y is the times that they're racing this race in, so I don't need negative 10. So I'm going to go 0 to 50 because I could see that my graph started out at 43. I could go 45. How about that? I'll go 45. And then I'm going to make each tick mark worth 5. And then I'll leave the rest of this stuff alone, and now I'm going to press graph. So there's the women coming along like that, and there's the men. And they haven't quite hit yet. You can see you're heading for it, but it's not there. So go back to the window. You need to see more to the right. So you've got to make this number bigger. So let's make it 120. Just see what happens. And then press graph. There's the women. There's the men. Oh, we're almost there. Not quite. Got to go back. Window. Let's make it 150. I'll press graph again. So you might be thinking, how would I know 150? You don't. You keep trying and trying and trying until you find the thing where they meet. Oh, it looks like they're just hitting at 150. I'm going to go 200. 0, 200. I really want to be able to see that intersection. I want to see an X, kind of an X shape there. And if I don't see it, then I haven't gone far enough. There you go. See the X? See how you got a little bit of gap on this side? Blue is higher on this side, lower on, and lower over here on this side. That's what you need. So now I'm going to go to second calc, number 5, enter, enter. And since there's only one intersection, you actually can just press enter. But if you like, you can move to the right and get closer to where you think that intersection actually is and press enter. And there it finds it. So I'm going to take that back and type it up. Men and women will have equal times in 1970 plus 150. So 1970 plus 150 would be, oops, hold on one second. There we go. The model predicts that men and women will have equal winning times in 2120 when they will both win at the 500 meter speed skating race in about 17.4 seconds. And over here on the left, you can see how I got the 2120.